Greetings, student. This is a recording of one of Garnett's online math lesson classes. You have been granted access to watch this video because you're a paying student and I have seen it fit to provide this recording to you. However, it is important that you know you're not allowed to share this video with persons outside the lessons. This policy is so that my services are kept only to my students. Thank you, and I do hope you enjoy and learn from this video.
So you can read the question. It says the diagram below, not drawn to scale, shows two ships, R and S, right? R and S are two ships at an anchor at an anchor. Yeah, at an anchor on a lake, sorry, of calm water. Right, so we expect they're not moving. And FT is a vertical tower, FSR is a straight line, and RS is the length of RS is 150 degrees, 50 meters, sorry. The angles of elevation of T, the top of the tower, and R from R and S are 22 degrees and 40 degrees respectively. F is the foot of the tower. Now, essentially, this is the diagram you would get from this information. So they already draw the diagram for you. So you're looking at two triangles, right? You should spot these two triangles. And there's also a third triangle here, right? It's good to see those shapes. Right? It's a composite shape. See all the shapes within it. So you have a huge right angle triangle here, and we also have non-right angle triangle here and a right angle triangle here. Okay? Now the first question asks, measure the angle. Remember this symbol, we have this symbol here is an angle, right? So the measure of angle RST, so RST, and that's the angle here. Wait, let me 1 second, let me actually write this in.
There's RTS.
RTS. Sorry. Thank you. Yeah. There's a few ways you can get this. Right, good. So, like Ryan correctly corrected me, right? RTS, angle RTS. Right. So we just follow those lines. RTS. I'm looking at this angle over here. Right? Looking at this angle here. This would be the angle RTS. Good. So what would be the measure for this angle RTS? How would you go about calculating this? All right, so no one's saying. So they said, you know, this is a straight line. Well, they indicated that FSR. This line is a straight line. And we know angles of a straight line is 180 degrees, which means that this angle here is 180 degrees. This angle here is 180. Making a full, well, half circle, it's 180 degrees. So if this portion of the angle is 40 degrees, then of course this other portion, we know this entire angle is 180 because it's a straight line. Then we can actually find this angle. This is one approach that we can use. We can actually find this angle here, and that is 180 subtracted by that 40 degrees. Okay. And that is, of course, equal to 140 degrees. So now you know this angle here is 140. Let me just take this out. And so now we know this angle here is 140. I can't write this any smaller. Right, you know this angle here is 140. So you have a triangle, right, that we pointed out earlier. So now you would be able to calculate this angle here. And now you would be able to calculate this angle here because it's within a triangle of which we know two of the other interior angles. So that means automatically that to get an angle, we know that the interior angles of a triangle sum to 180. So you can just add the two other angles, the two known angles, and subtract that from 180 to get that angle. Right? To get our angle RTS. All right, 162 subtract 180 subtract 162, that would be 18. We expect the angle to be small. Right? So angle RST is as simple as 18 degrees. Right? So just watch out for that, right? Look at one thing with triangles, just remember that especially that interior angles rule, it comes up a lot when you're looking at triangles. All right, good. So we know this angle, this small angle here will be 18. Will be 18 degrees. So we've calculated that. And by the way, this is worth 1 mark. We can move on to the second part of the question. And it says calculate the length of ST, right? So we're calculating the length of this line here. Good, right? So what we can do is, we're calculating the length of this line here. And what we know is the information, all of which we know, most of which we know is the information for this triangle here. So what you can do is extract the triangle just so you guys can see that a bit better. So I'm just extracting the triangle from the problem and writing it back here. I need to write it a bit bigger so you guys can see. So we can put in those angles. Good. So the first thing we know, this would be 22 degrees. And we know this line, this would be S, right? I'm taking this R to S, right? So this would be our R, 22, and this of course would be 150 meters. And we know we calculated this to be 140 degrees, and we've also calculated here to be 18 degrees. And this would be T. Now what we want to know is the length of ST or TS, whichever, the length of this side, right? And one way we could do that is to think of our sine and cosine rules. And the reason why we know we have to think of those two rules is because it's the only rules that we can use to get lengths of non-right angle triangles, right? So right away, think of cosine or sine rule. Now you've only learned, you can actually use, you could more, no, you can't. You can't use your cosine rule, fortunately. Okay? And I haven't showed you guys cosine rules yet, but sine rule is the only rule that you can use in this case. And the reason why I know that is because remember, if you recall, the note that I gave you is that you can apply your sine rule once you have two angles on a side or two sides on an angle. Right? So once you have that kind of information for your triangle, your non-right angle triangle, you can use your cosine rule. So we have not just two angles, we have three angles. We have all three angles, which makes sense. If you have two, you have all three, right? And we have a side. So we can actually use our sine rule on any side, right? To solve for any side. So ST, we can solve by using our sine rule. So what we can do is we can label ST as common R, again, using the convention opposite S. This would be common S, and this would be common T, right? Just so we stick to that convention. And we know that sine rule says that the length over sine that angle, the angle opposite that side, is equal to the ratio of any other side divided by sine the length, the angle opposite that side as well. So we want to know this side. So the pair that we're looking at is this side, and the angle opposite this side, which is angle R, right? Or angle SRT, whichever you prefer to say it. So R, or ST, right, divided by sine R. Right? I'll actually do this. Let's write it with our conventions and then substitute. Right? So R divided by sine R, we know sine R speaks of the angle at R, is equal to, and then we can use any other ratio we want. Of course, we have to use T, right? Because we know the length and the angle for this pair, right? So sine, so we have T divided by sine, the angle at the angle opposite that length, right? So now we can substitute. R is ST, that's what we want to find, divided by sine, capital R is 22 degrees, is equal to T, 150 meters, divided by our sine, 18 degrees. So we have this, we know we can transpose, we can solve for ST by transposing sine 22 degrees. So ST would be simply equal to 150 meters divided by sine 18 degrees. Now the sine 22 is going to be multiplying. And we can solve this. So what would ST be equal to? Assuming you guys are following along with your calculators, what would ST be equal to? Take your time and put them in. You can work this first and then multiply, or you can punch this all together in the calculator. Just make sure you're doing it correctly. So what STB? I'm waiting. And it asks for the answer at 1 decimal place. Forgot to find this out earlier. So origin 801.8 meters. So let me just double check. I prefer for you guys to be using your calculators and following along, right? That's correct. Right? Let's move on. It says to calculate the height of the tower FT. I'm not going to move on to that. You should know how to do this. It says to calculate this height FT. Now we just calculated STF. We just calculated ST. ST as 181.8 meters. You can go ahead and calculate this. And this is a right angle triangle, so we won't be using our and proceed, right? So the same laws apply, right? Non-right angle triangles, right? The same rules apply to this non-right angle triangles. But there is one criteria and one criteria only that you need for your cosine rule, right? To find to use your cosine rule, you need actually two criteria you need to solve for the cosine rule. So again, reminding you of how you should label the triangle and its sides, just so that you use the formula correctly. The reason why you're doing this is not because of is not only because of convention, it's so that you can apply the formula correctly, right? So you know how to use the formula, right? Because if you don't, then you're gonna build up with problems, right? So remember, it applies to the sine rule as well as the cosine rule. So remember this convention again, capital B, the side opposite capital B will be common B, same with the capital C and capital A. Now, for calculating the unknown side or angle in a non-right angle triangle, we can use the cosine rule. And the cosine rule says that A square is equal to B square plus C square minus 2BC cos A. Right? Now, this one is a bit longer to remember. Now, you will have a formula sheet, but I can tell you it's actually not that difficult to remember if you've been doing it enough times. And also, I'm going to show you something that can help you to remember it easily. Right? So, looking at this formula, there's two ways you can remember this formula. You can either remember it with the A being squared, or you can remember it with the A being the square root, with the A being unsquared, right? So instead of you having the A being squared, you transpose the square and it becomes square root of B square plus C square minus 2BC cos A. Now, sometimes it's taught like this because you'll be solving for A, right? You'll be solving for A, so you not A square, so you would end up having to transpose, and you will still end up having to carry over the square, right? So you could remember the formula like this or like this. Either way, you should end up with the same answer. But what this formula is trying to say is that B squared plus C squared, if we look at this triangle, is A is the length that we're trying to calculate, right? A is equal to, so that's what we're calculating. So this, where's my cursor? Okay, that's not seeing that better. Right? So this side, they're saying that the length of this side, A or BC, is equal to the length of this side squared is equal to C square, B square plus C square minus 2BC cos A. So if you notice, the stuff that I've circled are what I would call on a V. Right? The stuff that I circled are what I would say is on a V. Right? So you can think of cosine and even cos. Cos itself looks at V's, right? Even with the trigonometric function cos, the trigonometric ratio cos is adjacent over hypotenuse. It's a V, right? You will see a V each time because cos deals with V's. When I say V, I'm referring to, yikes. Let me just draw this here. Good. So when I say V, I mean that what you will always see with your cosine rule is a V, right? Meaning that two sides and an angle, right? That's what you will see, and it's on a V, right? Again, it's on a V, meaning that we say it's on a V because you have all the information within the V. You have the two sides and you have the angle in the middle. So this is what we call a complete V, right? So the cosine rule applies to a complete V. Once you have a complete V, you can use the cosine rule to find the length of the opposite side, right? To find the length of the opposite side, you can use this cosine rule. Going it over again, right? Going it over again. Once you spot that you have a complete V, right? Like what we have here. Well, we have all of them filled in here, but on a triangle, we might not have all of the angles filled in. What we might have is something like this, right? This time we have the length of this side. Let's call this C and B, and you have the angle in the middle here. So we have a V, right? So we have a V. We have an angle and the length of the two sides that constitute that angle. So once you spot this V, and I'll show you, we'll work enough examples so you guys can see it over and over again, that you will always have a V when you're using the cosine rule, right? So you always have a V like this, right? The two sides and the angle in the middle creates that V. And what you're using the cosine rule to do, because you have this V of information, you're using the cosine rule to calculate the length of the opposite side. And that's what this rule, this formula is saying, right? So now that that's how you identify that you need to use a cosine rule. Once you spot that V and you want to find the length of this opposite side, you can use the cosine rule. So that's a bit of how you know that. I will make a note of it. I'll make a note of it on the side just now, and then in the next slide. But what exactly is the V? So we have our V, right? A and the two sides. Let's call this side. Okay, so Josiah and Rayan, right? So we have this side, and we want to calculate this side. But we have this V information. We have the information on the V. I want to calculate the length of this side, right? And we notice the length of this side will be common A because this is capital A, right? The length of the opposite side is common. Good. So we notice, and what we want to calculate is this length, and we have the V. Now, without even looking at the formula, because these might not be labeled as A, B, and C, as we would have clearly seen before. It can be labeled PQR or whatever the case might be. So what you need to remember is actually that the length of this side that we want to find squared is equal to the two lengths of the V, the sum of the two lengths of the V squared, meaning that we square the length of one side, so square the length of one side, plus the square of the length of the other side, minus 2JR. So you're just going to multiply the two sides together. So far, we're just using these two sides. Again, it's the V, right? All the information we're using is on this V. So writing it back. Okay. So we identify we have the V, and we want to find for that unknown side. So the cosine rule is telling you that this unknown side squared is equal to one of the lengths of the side on the V, which we will use as J, plus one of the length of the other side squared, minus 2 multiplied by one of the lengths of the one side multiplied by one of the lengths of the other side, cos the angle, right? The angle within that V, right? Again, so that's how you remember the cosine rule. You can remember it as the square of these two sides, the addition of the square of these two sides, subtracted by 2 multiply these two sides, and then cos the angle in between those two. Now that is more or less one way to remember it. You can't just now of course you have your formula sheet, but if you could remember it like that, it's better for you. You don't have to go back to the formula, and you move a bit faster like that, right? Again, going that over, the length of this side, the side opposite, which is what we want to find once we identify this V, is squared is equal to the length of these two sides, the sum. So you're adding the square of these two sides, and that's what you do at the first portion here. And then you subtract 2 multiplied by those two sides, and then cos the angle in the V. Good. So let's look at our first example. And of course, the triangle is not drawn out for us as yet, but we can draw it. Okay? So good. So in a triangle ABC, A is equal to, and this is a common A, pay attention to that. Well, you know it's not an angle because it's a length here, but right, is equal to 12.8 centimeters. C is equal to 15.3 centimeters, and capital B, or the angle B, this hat, okay, tells us that this arrow hat tells us that is an angle 39.5 degrees. Evaluate the side B, right? So we have these three sides, and you notice we have two sides and an angle, right? Now, let me actually, let's work on this example first before I make the notes that I promised you guys I'd make. Good, so let's label A, B, C, that's what the triangle is. And on side E is 12.8 centimeters. Now again, do not forget this, the angle, opposite side, common B. Okay? But so and the side C is 15.3 centimeters, and angle B, so the angle at B would be 39.5 degrees. And you notice right away that you have a V, right? And I said to look out for that. You have a V, right? You have the angle. You have the angle in the middle, and you have the two sides. You have the two sides. So you have a V, and what we want, when you're using the cosine, we have this V. We're going to be solving for the length of this side, and that is the side B. So that's the side we want to find. So we know we have to use the cosine rule. In other words, in a nutshell, we're going to be using the cosine rule, right? And that's the steps you would use to tell, right? Now, let's calculate. Now remember what I said before, right? So this side squared, that's what this is the cosine rule, and this is the way I want you to remember it, is that this side squared, so the side that we want to find, right, this side opposite our angle, is that side squared would be equal to one side squared, so we're going to say a squared, and the other side, again, on our V, plus the other side squared as on our V, minus 2 times that side and that side, the multiplication of those two sides are 2 times A times C. These are all multiplications. Right? Cos the angle within our V, which is the B, right? I'm writing the symbols and not the plugging in the values as yet, but you can go ahead straight away and plug in the values if you already, actually best to write the formula first and then plug in your values. But you could go straight away and plug that in to save time, right? Good. So we have, this would be our cosine rule formula, right? Because again, we know that the sum of the squares of those two sides minus the multiplication of those two sides, cos the angle between those two sides would be equal to the square of the opposite side to that angle, right? So that's what we're going to look at, and that's what we're going to use to solve. So we're solving now. So b squared is equal to, let's plug in our values. So a is 12.8 centimeters, and this, now trust me, this is going to take a bit of time because the sine rule, like I said, is a bit longer. The cosine rule, sorry, like I said, is a bit longer than your sine rule, so it takes a bit longer to plug in all these. It's best not to plug in all these at once, right? In your calculator, you might miss something. You might mess something up. A greater chance of messing something up, actually. So let's just plug in all our values. 2AC, and then cos the angle, which is 39.5 degrees. So let's continue. So again, b squared is equal to this. So let's square 12.8. So again, I want you guys to double check my my calculations just to ensure, and to ensure that you're getting the same values I am. Right? If you have a problem, let me know, and I'll see how I can correct. Okay? So we're taking our time and plugging in these values one by one, and then computing. Right? If you feel you can plug in more than you can operate more than one stuff, be careful. But I would say go right ahead. So I'm gonna plug this entire thing into the calculator, because this is just multiplying, all multiplying by each other, and I can easily do that. So 2 multiplied by the 12.8 multiplied by the 15.3 multiplied by our cost, open bracket, 39.5 degrees, close. Now you don't have degrees, so forget I said that. And then press enter, we got something like 302.23, right? I stopped at 2 decimal place. The reason why I stopped at 2 decimal place is because I noticed my other answers have 2 decimal place as well. Now, as it relates to units, all right, so I haven't been putting in the units. Let me write this back. I'm going to write everything back. No, I haven't been putting in the units, but here would be centimeters squared plus 50 would be 234.09 centimeters squared. Now the reason why this is centimeters squared and I put in this, yeah, because you square the number as well as the unit, and in this case as well, this is minus when I plug all this in and I get my 302.23. This would also be centimeters squared, and this makes sense because if I multiply 12.8 by this 15.3, I will also have to multiply the units by each other, and centimeters times centimeters will give us a centimeter squared. So that's how I end up with centimeters squared for each one of these, right? And continuing, we can add these numbers and subtract. So 163.84 plus the 234.09 would give us 397.93. And this is 30 centimeters squared, subtracted by our 302.23 centimeters squared. So just bring that back down. I just bring this guy back down. Now we can do the subtraction. Now you notice that this value is larger than this value, so I will never end up with a negative. So you should never end up with a negative when you reach your final answer. If you do reach your final answer, you end up with a negative. You know from before that I taught you since the one rule that I've taught you since the beginning of time is that we can't square root a negative number, right? So watch out for those. If you get a negative, you won't be able to square root it. So you have to go and check back the calculations, right? So if you get any negatives during these calculations, just note that you did something wrong right away and double check back, right? But so we end up with 95. This is b squared, right? We want to know what b is, not b squared. So we have to transpose that b, right? So I'll just write this in this corner here. Right, so what we're left with is that b squared is equal to 95.7 centimeters squared, right? And yeah, right. So we want b, not b squared, so we gotta transpose the square. Carrying over the square, it becomes square root, and this is where I was talking about. If you had a negative number, you won't be able to square root it, so you know that you'll get error. So you know that you went wrong somewhere prior in the calculation. Good. So now we're square rooting 95.7. So the square root of 95.7 is about 9.78. I stopped at 2 decimal places. You can stop at any decimal place. And centimeters, right? We're left with centimeters alone because if we're square rooting a cm squared, that also becomes cm. Right? The square root of this here. So we square root a number as well as the unit, and we end up with our answer. B is actually equal to our right. This is the first example. Any questions or correct? Good. So we have this. This is the note, and this note again is to tell you when to use the cosine rule, when you can apply the cosine rule. So similar with the sine rule, because you notice the two angle and the two sides and an angle applies to our sine rule as well, right? If you have two sides and an angle, you can actually use the sine rule. But the difference between the cosine rule and the sine rule is that angle needs to actually, for you to use the cosine rule, the angle needs to be between those two sides, right? It needs to be the angle between those two sides. That's how you know you can use the cosine rule, right? Again, the V, right? So just look for the V and you should be fine. Now the second note is something that I didn't say, but you can actually use it to when you have all three sides of the triangle. So if you have all three sides of the non-right angle triangle and you want to find for an angle, you can actually use the cosine rule, right? So this is what I was talking about, right? When you want to calculate the angle. So now we're calculating the angle now, and it's a bit different, right? Well, it's the same formula, but the approach is we got to do some rearranging to find the angle, right? We're solving for the angle and not the side. Right? So again, you need to look for the V, but the angle in the middle is missing. So the V is there, but the angle in the middle is missing. So given the triangle below, calculate Q. right? Calculate the angle Q. So this angle here, theta, we're gonna call it theta, is the angle that we're looking for. So we're looking for this angle, and the only thing we have is all three sides. And this is what I said, you can use the cosine rule to find the angle when you have all three sides of the non-rectangle triangle. Okay? So what we have here, we still have a V because what we're looking at is still a V because we have the two sides. We're looking at the two sides and the angle in the middle, but the angle in the middle is unknown. So we just have to plug in Q, but we also have the angle opposite, the side opposite, right? So we're not finding this. So let's plug in it as if we were finding for this side. And as you would do, you have your V, but you don't have the angle in here. That's fine. You just plug it in. We plug in what we know, right? We plug in what we know. So use the same approach, do everything the same and plug in, and just plug in what you know, and that should guide you as to what you're going to be doing, right? So again, we're looking at our V, right? And we know for that V, the length, well, again, let's use this convention, right? The side opposite is common Q, right? P, this would be common P, and this would be common R, right? So the two sides of our V is R and P, right? So what we know from our sine rule is that Q, actually need some space for this, so I'll take this here and then continue. So just split this like this. Good. So Q squared, we know the side that we want to find squared, well, the side we would have wanted to find squared is equal to those two sides on our V's, the sum of the squares of those two sides on our V. So R squared plus P squared. I should have actually asked one of you to give me the form, what would be the formula in this case, but I'll do that in the next example, right? Multiply by 2, and then the two sides R and P, cos the angle within our V, and the angle within our V is actually unknown, and it's Q, right? It's the angle Q. Okay? We can put our hat on it. So the angle, so now you know your cosine rule, you know this formula. Let's actually plug in what we know and see if we can find Q. So Q, we actually know this side, the side that we want to find, we would have wanted to find is actually known now. It's actually 9.7, right? Centimeters. And we're squaring this because it's Q squared is equal to R squared. R is 12.5 centimeters squared plus P. P is the other side of our V. That is 5.4 cm squared minus 2 multiplied by those two sides. So 12.5 centimeters. Okay, this line needs to go at 5 multiplied by, so R P now, so 5.4 centimeters, and cos the angle, and we don't know the angle, so we just leave it as an unknown, angle Q. So we can actually do some multiplication and solve and then transpose to get Q, right? So let's do that. So let's square all what we need to square and do all the multiplications we need to do, right? So square 9.7 squared will give us 94.09. And this will be centimeters squared because we're also going to square the unit. And 12.5 square subtracted by our 2. Now we can only do this portion, right? We can only multiply up to this, and then you have to leave it multiplying the cos. So it's 2 multiplied by 12.5 multiplied by our 5.4. We get something like 135, right? And it's still going to be multiplying by the cos Q, the angle cos Q. Right? So we can add these two, right? So we still have our 94.09 centimeters squared equal to our 156.25 plus the 29.16. We have it 185.1, and again this is still being subtracted by 135. cos Q. Okay. All right, so good, right? This is still centimeters squared, by the way. Let me write it back. The cm squared stays. Cos Q. Now let's transpose, carry this over the equal sign. Now this is positive. When it goes over, it becomes subtraction. So you're left with 9 to 4.09 cm squared subtracted by our 185.41 cm squared. And this is equal to what's left over on this side, which is the minus 135 cos Q. Now we can actually do this subtraction. So 9 to 4.09 subtracted by 185.41. And this is negative. All right, so I will separate. So negative 9 to 1.32. And this is still centimeters squared. And this negative is fine because we have negatives on both sides, right? This would equal to our 135 cos Q. But so now we want to transpose our 135. Because again, we're finding for Q, we're going to keep carrying this stuff over the other side. So negative 135 or minus 135 is multiplying. When carried over becomes division, negative 135. So you end up with cos Q is actually equal to this negative 9 to 1.32 centimeters squared. That was already over here, divided by our negative 135. Right? Now, division, what do we get? It's something like 0.676444444. We'll stop at 4 decimal places. Again, that's just something I chose. And this would be equal to cos Q. Now we want to find Q, the angle Q, not cos, the angle Q. So you have to transpose this cos, right? This cos. So we have to carry the cos over the equal sign, and the cos being transposed over the equal sign will leave the Q by itself over here now. But instead of cos, it will be cos inverse. Once we transpose a cos over the equal sign, it becomes cos inverse, whatever was already over the equal sign, and that is our 0.764, right? So, and again, put that in bracket. So it's cos inverse, whatever is already over here is going to go into that bracket there. So Q is equal to cos inverse 0.6764. And you guys will tell me the answer for this. Cos inverse 0.6764 is equal to, so enough, that will be our final answer. What is that? Something like 47.43 degrees. Of course, it will be in 7.4, more or less 4, right? If we round up, we would have to round up, right? Because the number next is actually greater than. Good. All right, so that is it, right? That is it. Looking at our triangle, the third example is asking for us to calculate. In the diagram above, we have a non-right angle triangle. So right away, cosine rule, sine rule, right? If you're gonna find a length or an angle, you're most likely gonna use cosine rule or sine rule. Now, before you do that, ensure that you don't have two angles already inside, and you can actually just find the other side by using supplementary interior angles of the triangle or supplementary. But find from the diagram above, from this QPR, calculate the length of PR. So we're gonna calculate this length at the bottom here, right? And if you want to, you can actually try and go ahead, jump ahead of me and try and solve it before me, right? But I'll be going through it. Right? So again, the first step, usually what we want to do is label, right? Label that triangle so that we can get the correct formula I don't mix that up. So again, common Q, R would be common R over here. P with this would be common P over here. Okay. So we finished labeling. Let's actually go and find PR, right? So we're looking at this length and we have a V, right? We spot this V right away because we have the two sides and the angle in between. And we know all three of these things. We can actually find the length opposite this angle using their cosine rule, right? Using our cosine rule. So right away, we know that we have to use our cosine rule to find this length PR, which is actually common Q, right? So what is our cosine rule? What does our cosine rule tell us, right? Well, we're going to do part A first, and then we're going to do part B. Our cosine rule tells us that Q squared, the length of the side that we're going to find, squared, is equal to the two sides, the sum of the two sides squared. So R squared plus Q squared. Actually, I said I would have asked one of you guys to tell me the formula. So use Rihanna. Continue the formula for me.
Sir, minus 2 RP. RP, sir.
It's PP, yes. I'm writing Q. Yeah, continue.
Cos, open bracket, angle Q.
Angle Q, the capital Q, right? Close. Wonderful. So yes, that's the formula, right? Because that's the two sides. That is our V, right? Good. So we have our formula. Just plug in and use the formula, and we should be fine, right? So let's plug in. We want to find PR, so we're gonna plug in instead of Q. We're gonna plug in PR. So let's go PR, and PR is being squared, right? Q is being squared. PR is also being squared. So PR is equal to R squared, and R squared would be our 15.2 centimeters squared, right? This being squared, plus P squared, which is 9.7 centimeters all squared, subtracted by 2 multiplied by R, which is 15.2 cm, multiplied by P. P is 9.7 centimeters. Now, right away, you can see why this sine rule is very taxing. There's a lot of calculations, right? So you got to punch. You could actually punch all this in your calculator if you know all of this correctly, but to be very careful with that. So I'm gonna cheat a bit, right? I'm gonna actually punch this in my calculator, square these, sum and square this verbatimly together at once. So 15.2 squared plus 9.7 squared, and I get my 325.13 centimeters squared. And now this is going to be subtracted by 2 times this times cos 30 degrees, right? So 2 multiplied by the 15.2 multiplied by the 9.7 times the cos 30. That will give us our 255.37, right? And again, I'm taking 2 decimal places because I know this answer is also 2 decimal places. And you know this will be centimeters squared. These answers will all be centimeters squared. And of course, PR squared is equal to that. Now let's just subtract the 2, of course, and we expect, oops. Let's just subtract the 2. We get 69.76, and this is cm squared again. So PR squared is equal to this. Now we want to find PR, not PR squared, so we got to carry over that square, right? So PR is equal to the square root. All right, so this is getting a bit too close to the bottom, so I might have to carry this over here. All right, so PR, yeah, so what I was saying is PR. What I was saying is PR squared is actually equal to the 69.76 centimeters squared. Okay. And we want to find PR, not PR squared. So let's carry over the square. It becomes square root. And the 69.76 centimeters squared is now being square rooted. And we just square root this, and we get our solution for And it's, again, we're just taking it as two decimal places, just because. Okay? So PR is equal to our, I do box around, so. Right, so PR is equal to that, to 8.35 centimeters. Right? Don't forget your units to actually use marks if you don't at least have the answers, your answer in the correct units. Right? Your answer. Right, yes, wonderful. As you see, you are doing it along with me. That's great. So you got the same answer approximately. All right, good. So I just choose to put the 3.5. You can use just the 4. It's not an issue. It's just a preference, right? There's not really an issue. That's so because I didn't really specify the decimal place. All right, so we've done the first part of the question. Next part is asking us, we can actually put, let's move on, and we can actually put this in our length of this side using our cosine rule we found is actually 8.35 centimeters. We could use the 4 if you want. Good, so we found this side. The next parts of the question says, part B is asking us to find the angle, determine the magnitude of angle PRQ. So we're looking at PRQ, right? So they want us to find angle PRQ. Luckily for us, PRQ is already marked off a bit, but that's this angle here. That's this angle here. Now, this is the angle we want. So I'll call this theta. This is the angle we want here. I'm not sure where you're going with the 8.35 minus 15.2 centimeters. I was actually sure you're doing there. But yeah, I'm asking what can you do to solve it? Well, what your approach would be. Now, we're looking for an angle inside this triangle. And there are really only 3 ways we know to find an angle, right? We can either use cosine rule, sine rule, or our 180 degrees sum, right? But we can't use 180 degrees sum and find it because we don't know 2 angles in here, so we can't use that. So we either have to use cosine rule or sine rule, right? So on to Rihanna. Rihanna, what will you do to find this angle? R.
Sir, I would use the cosine rule.
You would use a cosine rule?
Yeah.
All right, so you want to use the cosine rule, but if I told you can use the sine rule, you see how we would use the sine rule? We want to find?
Yeah, you have 2 sides and an angle.
Yes, right? We have 2 sides and an angle. You can actually use either one, right? You could use either cosine rule or sine rule, but which one is longer, which one is short, and which one you're more comfortable with? That's the one you would pick, right? So cosine rule is fine. Sine rule is also fine, right? You can use either one to get that angle, right? Because we have information for both, right? And this is one of the situations where that can happen. You have enough information to use either or, right? Either or. Can I undo? So use either or. So what I'll do is actually use the sine rule. Just so refresh your minds on the sine rule a bit. So you don't, we're doing a bit of cosine rule, but remember that your sine rule is also there. It's also an option to use. So just ensure you got that at the back of your head as well. So let's actually use the sine rule to get this angle here. And we know that our sine rule, we just work with pairs, right? Work with the angle and the opposite angle. So for this is one pair, and again, we can label a side, opposite would be P, and this side is opposite, common Q. So we know the first pair that we have to use, the one that we're working with. Right? And that is R, comma, R divided by sine, capital R, and the angle R. And this is equal to So you choose another pair that you know both the angle and the length of the side for. And that's the Q, right? We know this angle on this side and the length of the opposite side. So you can actually find this by using that. So we can use Q divided by sine the angle, which is capital Q, right? And using this, you can plug in and solve, right? So R, we want to find this guy. So R is our 15.2 centimeters divided by our sine. R, so what we want to find. You can plug it in as angle PRQ, same thing. It's equal to our Q, which is our 8.35 centimeters, which we solved earlier, divided by sine. Q1 Q is our 30 degrees. That was given. Now, you notice we want to find R, and R is in the denominator, right? So what I would say before you do anything was you have your subject in the denominator like this. What you can do is flip both sides, right? Remember when we were transposing and what we want to make the subject, if it's in the denominator, one way you can change it from being a denominator is to flip both sides, right? To flip both sides. So let's flip this side. We end up with sine R divided by 15.2 centimeters is equal to, we also need to flip this side, sine 30 degrees divided by 8.35. See? And if you're a bit confused as to why I'm flipping, the only reason why I'm flipping is because our unknown or what we want to find is in the denominator. And if it's in the denominator, then flipping is one of your best options. Another way to actually change it is either to carry it over and then carry this guy over, right? Is to bring it over, carry this over here first, because if we know that once we bring the sine R over, it will become multiplication, hence in the numerator now. And then we have to carry transpose these guys over back that side. Yeah? Just remember your tricks, tips and tricks, and how you could change the subject of the formula, right? Especially when the guy is in the denominator, when your subject is in the denominator. So now that we have it in the numerator, we can actually transpose. So we want to solve for sine R, but sine R for now. So we're going to carry over our 15, so we end up with sine R is equal to sine 30 degrees, 8.35. See, now our 15 is multiplying as it comes over the cosine, and we end up with sine R is equal to, and we can solve this. We actually solve this. So let's solve this. So sine 30 goes over 8.35 multiplied by 15.2, and we're left with our 0.9102. And now we can actually do some, you want to find angle R, not sine R. So we can actually, let's come over here now and just write this as sine angle R is equal to the 0.9102. And what we want to find is R, not angle R, not sine angle R. So we have to transpose our sine next. So carry on over sine, it will be sine inverse whenever was already over there and over that equal sign. So sine inverse our 0.9102. So sine inverse that, and we should get our angle as 65, right? So the angle R would be equal to 65.5 or 65, actually 65.5 degrees, and that is our final answer for this angle. Okay. So now, right? So now, and that's about it before I give you guys these exercises. Now I'll give you guys these exercises for homework, and also there's some additional exercises from last class that I'll give you guys to do, right?